Okay, so I was supposed to do this demo next month, and I would have been better prepared, so don't judge me too harshly. It is what it is.
I don't know.
Wanda called me last Friday, she said, you're doing the demo next Thursday. I said, well, I'm not ready for it. She says, I don't care.
Well,
You're doing the demo. Okay.
as long as it's on par with your last 3 demos.
You missed my last 3 demos. How would you know? Okay, nevertheless. We're going to discuss a whole giant topic of CNC. It's not your traditional wood turning. However, it's a very great tool, very modern tool that can go hand in hand with turning and flat work of any kind of woodworking. So I would like to go top to bottom. We're going to go through a project. We're going to make some coasters today with Gold Coast logos on.
Cool.
So this is something I was playing with over the weekend. Do it. Okay. CNC is a really big giant term that encompasses just about anything that connects to a computer and moves. There are CNC milling machines, there are CNC lasers, there are CNC turning machines. You name it, these days there's a CNC for it. But we're going to stick it to the basics. Something really simple. I bought this thing maybe 4 years ago on eBay for 200 bucks. I probably used it since then 6 times, and it's sitting in my garage. However, it's a pretty cool tool. You can do a lot with it, and it's a very small footprint, and kind of the reason why I bought it, because it's so little. Because I can stick it in the corner, and every once in a while I can do a turning, and I can do a nice top for it that, put somebody's name on. Because I do have access to a very large CNC machine, so I don't really touch this thing, but it has its purposes. If anybody think of getting into the CNC world, do not go spend thousands of dollars on the machine. I will promise you 100% you will destroy the first one you buy. It's like a car. You've got to learn how to drive it. Go buy yourself a cheap $200 one that you care for. Crash all the tools on it, because you will. Learn how to use it, learn how to use the software, and then go buy yourself something decent. Because I've heard people, oh, I'm buying a $6,000 laser. Have you ever used a laser before? No. Good luck with that. It's like anything. It's a skill you've got to have. Now, I do have to say one thing. It's very computer heavy. If you're not computer savvy, you're going to fight it and you're going to hate it. So this thing doesn't have any brains behind it. The computer does. In order to do a simple project like this, requires 3 different softwares that you have to know how to use. And it's the most difficult part of the whole thing, is to learn how to use the software that comes along with this. And we're going to go through it and we talk about it. Now, this particular machine is 3-axis CNC, so basically it moves in 3 different directions. It moves back and forth, left to right, and top to bottom. With the 3 different motions and proper set of tools, you can accomplish just about anything. Except for anything wrong. For that, you have to add axis number 4 that will rotate the piece for you. They do sell attachments for this thing, but attachment is like this big, and you get about this much from your workpiece to the tool, which really doesn't make any sense. So if you're going to put a rotary attachment to your CNC, make sure you got enough height for it. So 3-axis X, Y, Z, real simple. The computer will tell it, okay, we're going to move the spindle, which actually spins and rotates the tool, just like any of the handheld router is. Because all it is, there are some machines that you can actually just buy a regular hand router and stick it right on it. And all it does is it moves it for you. The same tools that you use for your hand routers can be used here, which I brought some, which is just a regular 1/2-inch router bit, will do wonders on this machine. There are some very specialized tools like the plane cutters. This is 1-inch diameter. I wouldn't recommend doing this thing by hand, because it'll rip your fingers out. There's some really fine little cutters that'll get to a very sharp point, which is used a lot in these things. And this is an engraving tool. Now this tool and this tool are identical. They both have 60-degree angle on them. They both got the very sharp point on them. I like this one better because it's heavier, less vibration, and it moves the chips out of the way. But they're essentially the same. So
all you're using is the very point on that one.
yeah. Now, this guy, let's say take a piece of 3/4 plywood, and you can plunge it all the way 3/4 in, because the cutter on it is full inch long. And you can get a really cool text and designs by showing off the layers of plywood on it. It's something you cannot do with this little guy.
Yeah.
But the length I cut on this thing is about 1 inch. When we're done, guys, come take a look at it. Be careful, they're really, really sharp. Now, some of the metal working tools, this is a regular 1/4 inch 4-flute end mill that's used for metal working. Does wonders on wood, hardwoods as well. You can't really cut like soft pine with this or poplar, but anything hardwood, oh yeah, it's amazing. And they do not get dull because they solid carbide, they make cut metal. This bit is probably 4 years old, it's been used 300 times. It looks brand new, you can never tell it was used.
Would it do the same thing on metal?
Oh, no, this is gonna last an hour on metal.
Okay.
Okay, so this is a typical spindle just like the router would. It has a collet system. It uses little tiny collets. These little guys. This particular one can hold up to 1/4 inch, and they go down to like 0. So you take your regular 1/4 inch tools, put that thing in there, tighten it up, and she'll be ready to go. The best set of wrenches I've ever owned.
Those little skinny flat ones are good.
Well, I'm going to tell you the reason why I never threw them away, these particular ones. This is the second spindle on this machine. The first spindle on the machine, I put those things away, I grabbed 2 regular wrenches, and I broke this thing right off.
Okay.
It's not designed to crank them down like I'm used to. So I said, you know what? These little guys will get broken before I can break my machine. So I'm going to use my little guys.
That makes sense.
So we have a tool installed in the machine. It'll spin, it'll do some nice engravings, hopefully, if stars will line up. Now,
How fast is that spin?
this one will spin up to 4,000.
Okay.
And
Is
we can
it
use all that.
variable speed or just only 4,000?
This is manually controlled.
Okay.
So basically you turn a knob and it'll do that. This machine is 4 years old, I think. The newer ones that come with the same controller box, the speed is controlled by the software,
Oh.
which is a lot better. But back then, technology wasn't there. I buy those blanks in Michael's, I believe. They're like 37 cents a piece. They laser cut, since we're talking about CNC. They make very nice coasters, real cheap present. I don't usually buy them for coasters. I buy them for scrap because they're nice piece to use somewhere and glue something to it. But since I haven't laid around, they're making coasters, so they make coasters. For your real project, you probably will use something nicer than this. You make a nice turn box and you want to put a nice little top to it, get yourself a nice piece of wood. Double-sided tape, nothing better. It'll hold real well. Now, I would usually put it on the center of the machine, but because I want you guys to see it, I'll move it a little bit closer to the end. And it doesn't really matter where you put it, because we're going to center this and zero this out anyways.
Do you have a particular brand of double-sided tape that you like?
Yes, I use this spec tape. This is, they call it Turner's tape. It's a pressure-sensitive double-sided tape. The harder you squeeze, the better it grabs. I use this for my turnings all the time. I have never had this fail on me, not yet. But all you gotta do is press on it, especially when you do something on the lathe, you put a tailstock on it, you crank it up. It is not coming apart. All right. This machine by itself, as I said before, real stupid, doesn't have any brains to it. But without the computer, it's not going to do nothing for you. However, it does come with a nice software that runs the software. And because I am who I am a special controller for the software. Because in my shop, I have this thing on one side, my computer's on the other side, and it's kind of hard to control the machine when you're standing here, because you can't see what you're doing.
Yeah.
So I bought one of those things, so like I shall connect it to the computer, go over to the machine and see what I'm doing. I'm gonna turn it on, it's under power,
How do you set that?
and she will move for us.
How do you set that?
So I'll show you now. So we're gonna get this close to the center.
It finds it itself?
It's not. There are tools that will help you find the center, but I did pre-mark the center with my center finder on this. I'm gonna eyeball this. See if I get it close. Whoops, wrong button. My bad. Close enough. Now, I'm not really, since the machine has 3 axes, you have to zero 3 axes. You have to zero your X, you have to zero your Y, and you have to zero your Z axis. Your Z axis should be the top of your material, because that's how I program everything. It's all in the program. You can program this however you like. I like to keep my tool off of the top surface of my material, because now I can program in the depth that I want to go into, and whatever number I type in, that's how much it's going to type.
Does that require a flat surface?
No. You can program however curve you want. However, anything outside of flat surface becomes a programming nightmare. Is it doable? Yes. It's going to take you hours? Absolutely. I'm not overly concerned with the height of this tool right now, because actually there's a special thing that does this, because it's the most common thing you're going to do and the most common mistake you're going to make is you're not going to zero your machine right. You start button, and all it's going to do is go bam right into the table. You break the tool, you break the table. It happens. I don't care how long you've been doing this, you have done it and you're going to do it again. And this is like that one step that everybody forgets to do. So, I'm going to point my machine to the center. I'm going to go to my software, and I'm going to say, this is my 0, this is my 0, and this is my 0. So, right now, all my axes are lit in green right here, and they all zeroed out. However, I would like to be a little bit more precise with my height. So I'm going to pick this up a little bit. There's a special probe that's gets put right under the tool, and a little ground gets put right on the tool. A little sub program. Auto tool 0 return. You hit that, say OK. The machine will move by itself until it touches that probe and come right back out. Now when I say I want to go back to the origin, my tool is touching my material. The height of this never changes. It's programmed in there. So any tool you put in there, it comes in and touches it. It senses the current between this and this, and it gives you a perfect 0 every time.
Except it's 0.005.
Okay, it's 5/10 of 1,000. Do you know how much that is?
A little.
Okay, your hair is 4 thousandths. This is 5/10 of 1,000. This is 9 times bigger than your hair.
Can you zero it?
Yeah, you can
Zero?
just manually go say 0 and then zero them. Yes, if
And
you
it'll
want to be
return
that
it
much, yes, it'll zero it. Now, this control is 4-place decimal. You see there's 4 dots after. All the programming software is a 3-place decimal. We don't pay attention to the last decimal because we don't program that exactly. Yes. I don't know why. I guess you can't really measure that exact with any hand tools.
You can't see it.
That was the pressure lowering on the space shuttle?
Yeah, but that was off by like hundreds of thousands.
I'm making it.
Yeah. Okay, so we got a piece of material in there. The machine is all ready to go. It still doesn't know what to do. So we're going to design and tell it that we want to cut it. I couldn't show you the actual software because I have it on another computer and I didn't have time to whatever in Igor, but I took some pictures. This is the software that I like to use. It's my personal favorite because I've been using it for 20-something years. I know it really well, and I use it at work every day. It's easy for me. It is very expensive and very complicated to use. I do not recommend it to any hobbyist because there's no point of learning a professional software and pay for it $6 grand a year if you're not going to make money off it.
What brand is that?
This is called SolidWorks.
Southworks?
Yeah, and I use it just because I have it. I'm good at it because that's what I do, and it's easy for me. There's plenty of CAD softwares out there that'll help you design. There's a ton of files already available you can go download. If you go to Etsy and type in the Excel file, there's millions of them that you can buy for like 99 cents. You don't even have to invent nothing. I don't really like using other people's stuff just because it's not original, and I have access and know how to do it my own. So, the reason why I like this software, this is a very dimensional driven software. It's not just a pretty picture. You actually put in how big you want it to be, how deep you want it to cut. You get to type in all the dimensions, and your end result will be what this thing is on. There are some free softwares out there that'll let you download a picture and it'll work with the picture. But this is going to be, you're going to look at it and say, I want it this big. That's as close as I'm going to get. With this thing, I can dial it to exactly what I want it to be. Is it needed? Probably not. But that's what I'm used to, that's what I use. So, this is a 3D software. It'll actually allow you to design your end product in the three-dimensional space. Anything you turn, anything you make, 95% of everything I do, I design first. I want to see how it's going to look like before I'm going to spend, especially segmented stuff, before I'm going to spend 6 weeks cutting my stuff. I want to see if it's going to look good. This will allow you to do this because it'll give you a full-size result in three-dimensional space. So once you have your piece designed, the machine still doesn't know what to do. The machine only understands 3 coordinates, X, Y, and Z, that's it. It's that simple. So there's another piece of software, and that's really an expensive one. This will turn the file that I loaded from the SolidWorks into a G-code, which is an actual XYZ coordinates that this machine will understand. So you can't just load this image in and say, cut me this. It won't. What the machine understands, and I should have opened this earlier.
Is this like V-carve or one of those?
No.
No.
This is, what you're talking about, the e-carve, is what I mentioned earlier. You load the picture and it'll print it for you. It works more like a printer.
Yeah.
It's not dimensionally driven. It's very hard to control. And the biggest complaint that people have is, I want to engrave my bracelet, but the letters come out this big. Because you can't control it. You can eyeball it, but that's as close as you can get. I kind of live in a very precise world, and for me, eyeballing things just don't work. I don't understand them.
Have you ever used AutoCAD?
Yeah, back like 30 years ago, before the 3D stuff was around.
Yeah. Is the stuff you're using easier than AutoCAD?
It's different. AutoCAD, original AutoCAD was a flat 2D world.
Yeah.
People still use it mostly in architectural stuff because 3D environments do not like houses. It's too big. Your computer doesn't have enough computing power to build a building in. So they still use AutoCAD in flat layers and designs because space doesn't matter. In a 3D world, it actually does. The bigger your part is, the slower your computer is going to run. And that's just how it is.
I work with AutoCAD, and I was just wondering if this program would be easier than that.
It is. They both have their own
Right.
purposes. So, you know, the architects, they love their AutoCAD and they swear by it. The mechanical guys, they love our 3D stuff. Hang on one second. Let me show you something real quick. I'm sorry, I should have had this open.
Probably do 2D.
So this is what the code that actually software generated that this machine can actually understand. And as complicated as this looks, it's actually really simple. If everybody remember basic math is nothing but x and y coordinates. That's all there is. Every single line is a movement of the machine. There are shortcuts like circles. There's a command G something, going to be towards the bottom, that says, okay, give me a circle 3 inches diameter. So instead of programming each movement, it'll be one line of code. Things like letters, that's not concentric, doesn't have straight lines to it. Every single line of this code is a movement of the machine. And it's really nothing more than x and y. The z is the height of the tool, where it's going to go and where it's going to move. So on something simple, something basic like this code is only like 30 pages long. Oh, no, this is really basic and easy and simple stuff. But you don't write it by hand. The software will spit this out. You don't know how to read it, and that's okay. It's not for you to read this, for the machine to read.
You're saying basic, you mean a basic thing or basic language?
Oh, I'm just saying, you're making a simple thing.
Something simple, not a basic language.
No, if you were to make something three-dimensional that will have a lot of contours, a lot of movement to it, this thing is going to come out 700, 800, 900 pages long. And it's okay. It doesn't matter. The machine will read it for you. You don't have to.
You don't need to look at it.
You really don't.
There was a guy at our club when we were meeting at the woodcraft store. I taught him to turn, and he made a box about that big and this tall, and the lid, he had one of these, and he engraved a lattice work across it and a Chinese dragon in the middle of it.
Well, his code was like
And
this book.
He said it took him 14 hours to program it.
I believe it. I believe it. Now, here's the best part about it, and here's the
So
good part.
here's the question.
Yeah.
Will you do stuff for us?
No.
Well, that was pretty fast.
No.
Maybe if you ask nice enough. But here's the trick to the whole programming thing. Everybody hate it and everybody complain about it. But people don't understand you do this once. I've programmed this. 5 years from now, I go turn this stupid thing on, I go find my program, and it'll give me exactly that. I never have to do it again. But the trick to all that, you gotta label your programs. Because the machine will automatically save them as program number 1. 5 years from now, I promise you, you're not gonna remember what program number 1 is. So you gotta label it, you gotta put a name on it, you gotta. So this is a those turning demo, that's it. So if you guys gonna ask me again in 5 years to do this, I have everything ready. And programming only gets done once. You play with them, you fine tune them, especially if something you're making. These machines are great of repeating things. It's not really good at one-offs. It's time consuming. Now for us as a hobby, time consuming is okay. We can spend a week in programming and come out with one piece and we're never going to do this thing again. However, if you want to, you can. But the next time it'll take 5 minutes.
You can, like, say you want to make a change on that. Is it fairly simple to go in and say, right in the center little part, you want to do a little flower or something?
Yeah.
You can just
You
change
have the
this
base
and
already.
add
If
to
you want to
it.
add something to it, you can leave this alone and add another section of the code or completely separate code. As long as you don't take the part out of the machine, you can run 3, 4, 5, 7 programs. Now, this is a single tool machine. It only holds one tool. So, if you have a project that will require a couple of tools, let's say you want to put a radius on it, right? You got to put a radius bit on it. Because you're going to change your tool, it's going to be a whole separate program. So you're going to run your program first, and you're going to take the tool out, put a new tool, and run a different program. And you can do this as many times as you want. Now, I have a machine at work that has 27 tools. They're preloaded. So I write everything into one program. Something like this, you can't.
Yeah.
So for every tool, you write a separate program. So you can over and over and over again. We all like to stick our name on the bottom of things, right? You make one of those little things with your name on it. This whole thing will spit them out hundreds of the time.
Right.
All you gotta do is just keep loading a blank. If you're gonna do that, you make yourself some stops. So every time you put a blank in the same spot, and you don't have to do nothing, you just hit the start button and the machine does it for you. So this thing is really, really, really good at getting something complicated done fast and repeat itself. Now you can do this by hand. There's people good enough to do this by hand. Do I ask you to do 100 of this by hand? No.
Not gonna be the same. So that one tool
Yes.
does everything
That
else
does
that.
everything here.
Got it.
Yeah. I try to keep things simple here just because I have one tool. It's a baby toy. It's very, very limited to what it can do. I don't like it because I'm not used to the abuse. Because I'm used to, 27 tools I can stick in there and do whatever the hell I want. This thing's not gonna let me. So I try to keep it simple. This is something I had to come up with really fast. The text is really easy to program because you just basically type the text in and I said I want it in a circle pattern and the software does it for you automatically. So this, for me, this programming took 15 minutes to do this. And now I can pump them out.
Any 2-year-old can do it with 20 years experience.
Yes. Okay, so.
And if you ask a teenager, they've got it.
Get rid of all that. Let's go back to our main control. This is what drives our machine. We're gonna load our G code in here. It says load G code. Pick one up. Excuse me. I think I pressed something wrong. There we go. So this control has a couple of sections. This will actually show you the end result because it pre-reads the G code. So you can kind of look and say, oh yeah, that's the right program. It'll give you a quick snap. Don't judge by it's not the exact size, but you can tell whether you loaded the right program or not. This will move together with the G code. This will actually read the machine movements and it'll show you. This is all your controls, start, stop, load the G code, reset the emergency stops. All of this is here. Tool information is here. If the machine has the auto tool, this one does not, so it kind of does this. This is your feed. This is how fast the tool actually moves. You pre-program this, but you can make micro adjustments as you run it, especially the first time you run the part. You think you're going to run it at that speed, at that tool, and that wood, and then you put a piece of wood that's harder than that, you got to slow down a little. Instead of going and changing your program, you can do the speed and apply, and it's really simple. This is the spindle speed, also for the machines that have the automatic, newer ones that will control the speed of the machine, of the spindle. This is done on this side. There's a whole bunch of other stuff that we're not going to get into. So let's try cutting some. Let's see if she cooperates. She's been a little finicky.
She's old.
In the computer age, absolutely.
It happened to all of us.
But eventually she will turn up.
It's horrible.
Emergency stop over
Oh,
there?
there she is. No, it's this. I think the switch is getting. I gotta get into this. So now it's speeding. I can slow it down. I can speed it up. This is about as fast as it's gonna go. I don't need to run this at a full speed because this material is soft.
How do
So-
you determine the feed rate?
First off, it's based on experience. Second off, you guess at whatever and you cut the first one. And you watch it, and this control will allow you to slow it down or speed it up as it goes. And the idea is you don't want this thing chipping out and breaking. And you also gotta listen to your machine. If you overloaded it, it's gonna cry. So you gotta either pick up the speed of the spindle or you gotta slow down the feed. So it's kind of a balance between the two. So,
So like wood turning, it talks to it.
yeah, you put a tool to the wood and if you take it too big of a pass, it'll fight you back. It's the same thing. Let's see what she does. The G-code goes through as it reads. The more it gets changed, the Z kind of always stays the same way because it's all programmed to the same way. That's how it moves. On this side, you can see what's actually doing. That'll let it flow and then it's gonna go around a couple of letters.
Now, do most of them with just one pass, but if you want something deeper, go back and
Go back to the second pass. Now, the ones that I showed you, this was one pass and I liked it. Then I tried the 2 passes and it was too deep. So to me, this looked a lot better than this. So I figured I'll leave it at 1 pass. You see the difference, right?
Yeah.
2 pass is the one that was sponsored. The 2 pass is the one that was sponsored.
Yeah, because it goes too deep and this material is so soft it starts breaking the edges off. Flaking. I mean, if we look at a nice piece of mahogany or something that's something hard and solid, oh, you can go half like deeper and it'll look a lot nicer. But for the sake of the demo,
So does it take into consideration the shape of the tool?
no, this thing is not that small.
So if you went deeper,
Yeah,
everything would, you'd have that angle.
now this is a 60-degree copper engraving is the most stubborn thing out there. I already can get them 90, you can get them 100 degrees. And then you can get a real white cast but not really deep. This is used a lot if you're planning to feel it later. Because you would go and get like a really wide tool to get a wider area to feel it in.
And if you're using a skinny bit with the same point, it can cause more vibration for sure.
Yes. Now, I've done those things before on a little bit bigger scale, just using a regular half reel with a flat bottom. I would cut it in there and then I'd fill it out with a colored epoxy. So this gives you a space for epoxy to stand on. I did a jewelry box for my daughter, I wrote her name on it. And I filled it in with green epoxy, it looks great. But it's personalized. See, the text is almost done.
On Facebook, I see sometimes where the cable will come down and touch certain parts of the piece to,
Brothers by Megan Roach?
on Facebook, I see these videos where the thing will touch different parts of it, will set the parameters, and then it'll do it.
Yeah, those are called automatic probes, and they use a lot in the metalworking. You can't do this on wood because the wood is not electrically conductive.
Oh.
Because it senses where the material is by not magnetism, the static electricity.
Electrostatic.
Yeah, so the wood doesn't work because you won't feel the wood, it'll just try to find the table.
But if you wet,
Yeah, but then you don't want to talk about wood either. Because,
it's gonna change.
What you do is you compress the wood,
We're doing the
you do
inside
your
circles
cuts, and then
now.
when you go flatten it,
Nice pretty flower out of it.
it's neat. Yeah, instead of,
I was gonna do the palm tree like they have on our logo, but anyway. I was not prepared. Thank you, Wanda.
What do you think?
So how much computer knowledge do you need to do this?
You have to be able to turn the sticker key on. That's about as far as, if you're willing to learn it, it's not hard, you're gonna learn it. You gotta put time in it. Now, this stuff is complicated. A lot of the hobby machines, you don't have to do all of that. There are software that will help you, there are software that will teach you. There are people who do the service, you send them your design, they'll teach you, and people are ready for it. So you can go as far as that. You know, you draw it on a piece of paper, you send it to them, and they'll send you the jiggle that you load in the machine and run. But it's fun. Opportunities are in there. You gotta get into it. Options on the outside circle, almost done.
On the deeper past one, the letters are not as crisp, it starts
You
fuzzy.
can start flaking out the material, but this thing is still soft.
Yep.
Alright? 5 minutes, 10 seconds. Do that with the router.
So why is the Z-axis at 0.25?
because I left it there because now I gotta take my material out and I don't want my tool touching it. My last step in the program, say move my Z 1/4 inch up. Sandpaper.
Like,
Done.
take one of those.
Now Lee is gonna demonstrate this by hand.
That's right.
On the lathe.
Yeah, here, leave. Go turn.
No, with the dental tool. Yeah. The dental tool.
I got my little Swiss Army knife.
Yeah.
Hey,
So I have a project that I wanted to do, and I have these little abalone fish,
Okay,
and they're all just slightly different.
okay.
How complicated would it be to do that, just to recess it a little bit, so that they'll sit down flush in the piece?
It's not complicated, it's time, that's all there is to it.
Yeah.
You know, anything we do here, it's not
I
complicated.
don't use computers at all. I mean, that's
Well, you're basically
just-
asking me if I do it for you?
No, I'm asking if you would help me.
I'd like to take a look at it before I say yes or no.
Yeah, I mean, it's just real simple little, bait fish or whatever.
Yeah, you show me what you're trying to do.
Okay.
I'll try to help you out.
Yeah, because I mean, that's like I said, I'm totally computer illiterate.
Why?
No, I
Because I don't use it in my life. I don't use it in my job.
You should.
Now you want me to sew something for you, I can do that.
Yeah.
Yeah, it's bigger
But
than
I-
There are
Seven.
new softwares that are Wi-Fi enabled and you can control it from your phone. You bypass the whole computer completely and you do the same thing from your phone. I don't believe it because the Wi-Fi connection, it loses in the middle, your machine will stop or it'll damage your piece or, I like shit connected, please.
So what is the 5th axis?
Okay, let's talk about 5th axis. This is a 3-axis machine, X, Y, Z.
Right.
There's 4-axis machines which you add a rotary tool to it.
Right.
There's a 5th axis when you take your Z axis and you start spinning that too. That gives you a 5-axis machine. Now, that's a lot of fun.
And
That you can get into a lot of trouble with.
What would you use a 5-axis on, for
Well,
instance?
Crankshaft.
stairwell.
Yeah, even the same thing. You have a piece of round something, right? And then you try to carve on it, but not straight down, but like this.
Okay.
So you want to do a swirly pattern with the tool sticking down inside the middle of the thing and doing one of those. You need a 5-axis machine for them.
Okay.
Yeah, they have their applications. They're very few. They're very complicated to use. They're really easy to crash because our brain doesn't really function in 5-axis.
Right.
So you can't really envision how this is going to be until you actually press the start button. By then it's too late. Yep.
There are some areas here which don't look that clean. Is that the program or is
No,
it
material.
it's the material. This is Bass something.
That's what
Yeah.
my brother-in-law he taught master cam
Yes.
in the high school for 4 years at Everglades. It was a 4-year program. Taught it for 22 years.
Where at?
Everglades High School, so whenever it opened.
Yes.
But he also, he just retired and he just picked up an 8-foot 5-axis master cam
Yeah.
mill that
He's gonna have a lot
got
of fun.
shipped to his house. He's very excited.
Yes, yes.
And I've never
very
really
good to
heard
know.
about the 5th axis.
Yeah. The 5th axis will allow you to do. I'll give you a simple term. How do you cut a countersink with a straight tool? You need a 5th axis. You need to turn your tool at an angle and do a motion.
He tried to explain it to me that if you had a stair railing that you were doing that was coming down and then did a turn.
Make the turn.
And
you get the
he
5th
said that's what
axis to do that.
5th axis. That's how he tried to explain it to me.
He's absolutely right. Okay. I'm done.
Thank you very much.